Okay, so now we're on question 5 of June 2018, paper 2. It says state Hooke's law. Hooke's law states that the force applied to a spring is proportional to its extension. Boom, bam, bam, that's it. And then number 2, with the aid of a label sketch graph, explain what is meant by elastic limit. So if you did an experiment based on Hooke's law, you would have obtained maybe a straight line graph, or if your spring got deformed, you would have obtained something like this if you plotted a graph of extension against load. The other way around, this will be bending the other way. If you put load against extension, this will be bending the other way. Anyway, so the elastic limit is referred to as plastic deformation. Once an object has reached its elastic limit, it cannot revert to its original length after being stretched. It is the point beyond which any further increase in the load applied to a spring will produce a permanent stretch. Okay, so that's that. Then now it says a steel spring has a spring constant of 2 times 10 to the 2 newtons per meter. Right? And it says calculate trying to get this to focus. It says to calculate the weight of an object which, when attached to the unloaded spring, produces an extension of 5 millimeters. The elastic limit is not met. So, think about it. They gave you the entire equation. So what you need to do is just transpose, because you're looking for the force or the weight. So the force is therefore equal to the spring constant, and the spring constant is k while the extension is x. But I'll just write back the whole set of words. The spring constant times extension. Okay, and the extension has to be in meters, right? Because the spring constant is in newtons per meter. Okay, so to find the weight, we have to say force is equal to 2 times 10 to the 2 newtons per meters times 50 times 10 to the negative 3, because remember, milli, that little m, stands for 10 to the negative 3 meters. Once that's under control, you cancel the meters, and now you have the units of force. And that will give us 10 newtons. Yay! Alright, so moving on. It says the object attached to the spring in B fell from rest. So rest will be equal to 0 meters per second, and hit the ground after 2 seconds. So time is 2 seconds. Calculate the velocity of the object on hitting the ground. And since it's falling towards Earth, the acceleration of the object will be meters per second squared. Right? 10 meters per second squared. That's why they give us this, because that's acceleration. And we have V, U, T, A, and we're looking for V. And we have the equation V equals to U plus AT. And since we're looking for V, we don't have to transpose, we just have to substitute. So we're going to fill in 0 meters per second plus 10 meters per second squared times 2 seconds. This goes, and so V is actually equal to 20 meters per second. Yay! And that's that for 15 marks.